All right, I'll be speaking super fast, so I apologize because there's a lot to cover. And here we go. So, JavaScript Monorepos 2025. I'll cover orchestration, lots of other things. So, my name is Victor. I'm the CTO and co-founder of Annex. Annex is a monorepo build platform and a monorepo build tool. Okay. So, why monorepos? I like starting with why, always not with what, because it's important to answer the question why are we doing it, like why we're pursuing something. The historical reason to use monorepos can be stated like this, right? As our organizations grow, different teams within our organization start carving out spaces for themselves, repos, and you can have dozens or hundreds of thousands of repos in organizations, and a single system could easily be composed of out of say dozens of repos, right? And it's done for like the sake of autonomy, right? And what happens in the long run that everyone builds a tiny fence around their repo, right? And that tiny fence prevents different things. So it prevents code reuse. It's much harder to use code across projects. Prevents context sharing. Team A doesn't know what Team B is doing, or it's hard to see, right? It's effortful to see, right? And most importantly, it prevents you from rolling out interesting changes across the whole system because often the whole system is in 20 different repos. So now you have to have this cascading updates across repos, multiple PRs, different releases. It is very hard, okay? And that's what we feel when we move from a small organization like a startup towards like a large organization, or we go and like work at a bank or something, right? That certain things are harder, and that's why, right? So the solution that many organizations try to come up with is like, let's group all the things together. Not all the repos, but like connected repos, the ones that are next to each other, that you change often together, right? You put them together in one space, the monorepo, right? And you put some interesting tooling around it to make it kind of work, right? And suddenly, you can see the context is shared, silos are broken, there's more code reuse. A lot of good things actually happen when you do it well, right? It's a wonderful thing, right? That's an old answer. It's still valid, good answer. The 2025 answer, right, that in addition to the other answer, is that if you use AI agents to work with your code, which a lot of people do right now, and more people will be doing in the future, AI agents really care about context. Like context is king, right? And if you have a system that's spread out in 20 repos, and your AI agent looks at one of them, it has access to 5% of the context. So it cannot make good non-local decisions, because no local decisions require you to understand the 95% that is not in that repo, all right? And AI agents cannot make, of course, code changes across repos easily, right? So it becomes very effortful to take advantage of the main killer feature of AI agents, which is making large-scale code changes quickly, right? Like this mega refactoring tool that they could be used as, right? Doesn't work as well, okay? So those are the two answers. So now, that's why. So what are the monorepos, right? It is hard to answer. I wouldn't say people don't do it well, all right, as much as there's just so many different ways to do it, where it's hard to know, are you actually using a monorepo? On one side, you have something like Bazel, which some folks like, and I also like it as well. That is a very powerful build tool that can support thousands of engineers contributing to the same repo very easily, right? But imposes many restrictions on how you do work in that repo, right? For example, single version policy is a common restriction where all your teams working on web apps have to use the same version of React, for example, right? The problem with those restrictions is it is hard to like drop a project into this repo. It won't work. Everything has to be wrapped, adjusted. The editors don't work, have to be adjusted. AI agents actually don't work really well, have to be adjusted. So a lot of costs, but big gains. And on the other side of the spectrum, you have something like PNPM workspaces or NPM workspaces. That's what JavaScript folks usually think of when they hear the word monorepo. It's very simple, easy to almost no restrictions, but doesn't scale particularly well because fundamentally what it gives you is basic cross-project visibility and some basic task orchestration, right? And that's useful, right? I use PNPM all the time, right? Just not sufficient for scaling, right? So what we are working on, what I've been working on for, one more thing about the analogy that I like to use crazy analogies, right? The Basil analogy is sort of like a freight train, right? If I want to move cargo from Toronto where I am to Vancouver, a train is a fine way to do it. Like how would you, like you should use a train, right? You can put a lot of stuff on it. It's very cost efficient. It works well. It is a bad way to do lots of other things, right? You wouldn't move stuff on a train from two neighboring towns necessarily. You wouldn't move stuff from one part of Toronto to another part of Toronto on a train. The infrastructure for the train is very expensive. It takes a long time to create a new railroad. So it's very powerful for few cases where it's needed. and it's not really applicable to a lot of other cases. PNPM workspace is like a bicycle, very useful if you want to Uber Eats from a restaurant. Bicycle is perfect, right? You can carry backpack worth of stuff. Everyone can hop in. Existing infrastructure could be used very easily, right? The problem with a bicycle is that once you start with a bike, you kind of, it works at the beginning. As you start scaling, you put more stuff on the bike, and then it becomes kind of tricky. It doesn't work, and very quickly you hit a point where no matter what you do to that bike, you just cannot scale it any further because there are fundamental limitations to the bike. Right? You cannot transform a bike into a train through gradual refactoring. Okay, it doesn't work. You need to start with something different, right? So what Annexes, which is a build system I've been working on for many years. In many ways, it's actually inspired by both of those, PNPM and Bazel. It's like the metaphor of the truck, okay? And the pterodactyls attacking it, as a competition attacking your business or something. I don't know. And the important part, you can move a lot of cargo in the truck. It's versatile, right? And it's very powerful. But it works with existing infrastructure, right? You can use existing roads. You can move stuff from one part of the continent to another one in a truck, but you can move stuff from one part of the city to another part of the city in a truck as well, all right? Much more versatile. Okay, so now the demo part. And the demo is going to be a bit chaotic because I'm going to talk about a few points of value that I would like you to focus on. So just bear with me, okay? So in general, if you want to create an Annex workspace to feel what it's like to drive this truck, quote unquote, right? You can go to annex.dev. You can click on Get Started, create a new workspace, pick a template, give it a name, demo, cool demo, right? And in a second after that, if it works, hopefully it works. Okay, you're going to get this page, right? And you can clone it, and you can like proceed with this example demo thing that you can then grow into a real system, right? Here I'm showing the whole Annex platform, which includes the build tool used locally, but also the CI part. You don't have to use the CI part. I just think for the demo, it looks cooler if I show you this, okay? I was instructed before the talk very clearly, do not run PM install, otherwise I'm going to be in trouble, okay? That's what I was told. So I ran npm install in advance in exactly the same thing that I showed you here. Create a separate repo. I cloned it. It's called demo prep, right? And this is the repo I have. It's set up, right? It's exactly the same stuff. There's nothing magical in here, right? It's just not modules in the right place, okay? So you can see in here, it's a simple workspace with a bunch of projects in it. There are several applications. There's a show application, an API, and there's a bunch of libraries that the applications are composed of, right? I will show you that this application works. Hopefully works, right? We'll never know. Okay, so it appears to be working, right? I can click on this URL, and I will see the app is working. Something is happening, etc. The important part here is not the app. We actually don't care about what exactly the app is doing because this talk is not about building front-end apps, right? It's about build systems and orchestrations and lots of other things. And what I want to look at in here is this TUI or TUI, right? This TUI serves both the front application and the API the application depends on. And prior to that, it had to build two things. It had to build a few libraries that those systems use, right? How exactly it's building it, forget about it for now. Not important. What I want you to think about is just the developer ergonomics the person gets, right? They see this TUI, they're able to pin some outputs, they're able to look at other outputs, they're able to do different things in here that you have to do, right? If you are working on a monorepo tool, right? Because what monorepo tools, you can do things like that, etc. What monorepo tools do, they let you run lots of tasks at the same time. Because monorepos have lots of things in them. Therefore, if you build stuff, you can easily build 100 projects that depend on each other. If you run tests, you can run 100 tests or hundreds of tests or thousands of tests at the same time, right? So being able to reason through it, search and interact with it is very important. That's a core property of a monorepo tool, right? So any monorepo tool that does interesting task orchestration has to come with some way for you to visualize it. And we do a good job at it, I think. We focus a lot on the core experience and being able to see this, etc., is the core experience of a monorepo, right? You should be able to know what you run and run many different things and be comfortable with it and find what failed where, how things depend on each other, etc., right? We, however, are not the only one who care about the core experience, about running things, right? Any monorepo tool, maybe not as successful as ours, I would argue, but they still try to attack this core experience and make it work really well, where you could see what's going on, right? everyone cares. You have to care, otherwise you're just a bad tool, right? What we do differently from other folks is that we care about non-core experiences as well, all right? The experiences that are very interesting at scale, but some people ignore, right? And here I'm going to open an X console, which is an extension we have for WebStorm and IntelliJ, and you can get the same for other editors like VS Code. And I'm going to open a project graph. And here I'm going to look at the same workspace I'm just showing you, right? The exact same stuff, but in a visual way, right? I could see that there are applications. I could see that there are libraries applications are composed of. I could see what libraries, some metadata about the libraries. I can click on the edge between different projects, between application and libraries, and I could see how this edge is constructed, right? Meaning that one project depends on another one because these two files mention that project. Therefore, the edge was drawn, which is important for any monorepo tool, which always works with graphs of projects, right? The important part I want you to focus on is not exactly what this graph is showing. It may be a little bit hard to read, but don't worry about every single thing that's written here. It's not that important. The important is to understand the value proposition. And the value proposition is that at some point, as your repo starts growing, being able to look at it in a visual way and make decisions about it in a visual way becomes more and more important, because otherwise you end up in a mess where everything depends on everything. You have this crazy spider web dependency graph, right? And being able to do it for this repo, the small repo, does matter. For a real repo with 1,000 projects, it does matter, right? It makes a big difference. And there are other affordances in here that would make a big difference, right? And the affordances such as I'm able to look at circular dependencies. This repo doesn't have circular dependencies, but a lot of real repos do, right? When we see people adding an X to say PNPM, you would see how many circular dependencies projects have. A lot, right? And you want to probably disentangle them, because that's usually not a good sign of design, right? Being able to visually see it, figure out where the circular dependencies are drawn, and what files add them, and come up with strategies of removing them to make the graph a nice cyclic graph, right? Is something that is an important capability. That is not a core capability of a build tool, but it's an important one at scale, because without it, you'll be in trouble, right? I'll give you another example of this kind of the focus on auxiliary capabilities that we have, right? If I open package.json for the show application, which is a small web app, and I click on this button on the side, right? And you will see, I'll make it a little bit smaller because the font is like massive, okay? So you'll see that Annex, the build system, looked at your folder, at your application, right? It looked at it, it examined everything about it, it deeply understood it, and it figured out all the things it can do with it. Like, you can build this app, you can dev it, you can land it, you can run tests, you can type check it, you can do lots of interesting things with it, right? One thing here that is missing is npm scripts, right? So often if you use JavaScript monorepo tools, you would have things like this, right? Go on to see, okay? You have npm scripts that do things, and they would invoke it. And you can see them here as well. Annex sees your npm scripts. You can run npm scripts via Annex. We, however, don't recommend you to focus too much on npm scripts for one reason. Every npm script is a black box. If you invoke vite build via an npm script, essentially you're saying there is a process that can do anything in there, right? So you need to configure your vite, and then you need to configure your monorepo tool to understand what you do with vite inside an npm script. And that's not great, right? So we don't like this developer experience. It's very error prone, and in general, it's not the best thing you could do. So how do other things handle this case, where you have essentially the core tool, vite, right? And something that is around it, right? And so what we did, we look at editors like IntelliJ, WebStorm, or VS Code, and what they do, they don't require you to configure a 20-line thing before you run a test. If you go to a project that has a Jest test, for example, you just right-click and say, run this test, and it runs this test. How does it work? In this case, the editor, IntelliJ, WebStorm, or not, looks at your project, figures out that you use Jest, and uses kind of plugin system or intelligence, whatever, to figure out that it can run those specs, right? And provides you affordances to run them, right? You configure Jest. You don't configure IntelliJ to use Jest, generally speaking. IntelliJ can figure out how to use Jest on its own, right? You get the value for free, right? We have the same developer experience, which we borrowed from the editors. You configure vite, right? And then Annex would look at your vite configuration, would configure itself, and you get the value, the optimizations and stuff for free, right? So for example, here I have the build target that Annex deduced for this project because it knows you have vite, therefore you can build stuff. I can run the builds, right? And it will work. I mean, it's already local cached because I tried it right before. Anyway, it will run, it will work. It will show you what's going to run. It's going to run with build. it will configure caching correctly, such that it's going to be a cache hit, it's going to be a free thing, right? Until you change some of the source files, or you change this external dependency bit in your node modules. What I want you to pay attention to is this output. Basically, this folder, this output, is what NX is going to cache and restore as you run the target. If I delete this folder over here and I rerun the thing again, you'll see this folder will appear again, okay? And it's important because it's configured over here. Like, how did we configure it? Did we have to tell NX that there is a this folder that Vite is going to create, so we need to cache it? No, you configure Vite to write to this. If I change this folder to this 1 to 3, it's going to be this 1 to 3, probably. Oh yeah, this 1 to 3, fantastic, it works. So I can change it back, right? That's an important property. Again, we were inspired highly by the editors. Do not configure anything twice. Configure your bundler, your compiler, and let the monorepo tool figure out what the bundler and the compiler are doing, such that they can configure, itself, and you get the value for free, right? And it's not just the value for free in terms of like ergonomics or amount of typing. It's also important for performance, right? If I look at the other projects here, which is an end-to-end set of end-to-end tests, right, for this application, right, and I look at package.json, I will see that in opposite to a more simple build tool, which would just have a script that runs all end-to-end tests, like the editor, NX would look into your folder, will figure out which test you have, and would let you run, like it basically would reason about each test separately, right? As you can see, this is this particular test, and all the tasks that have to happen for this test to execute, right? This ability to reason about your test separately in here is a key capability, not just in terms of developer ergonomics, it's convenient, that's fine, but also in terms of performance and scalability. Because now, without you having to do anything, all of those tests could be spread out and run in CI across different machines. They could be cached separately. They could be deflagged separately. We can do a lot of this stuff separately with each of those tests instead of the whole suite, right? So that's kind of the important kind of capability in here, okay? So just to quick summary at this point. So what's important? Core experience is important, right? TUIs, performance, etc. Being able to create big graphs of tasks you orchestrate, it's very important. We care about it. Everyone else cares about it, right? So yeah, you need to do it if you are a build tools engineer. Focus on those. However, what I think people should focus more on, like build tools engineers, right, is to look at auxiliary things like this, right? Something that is not a core experience per se. You don't have to have it, right? But it actually makes a big difference, especially at scale. Once your repo gets bigger, you actually need to figure out what is going on with it, right? Why is it slow? What is configured how? What are the dependencies, right? By the way, I'm showing you everything here in the editor, but if you are not an editor person, right, not an IDE person, but you like to work in the terminal, which oftentimes I do as well, you can run commands and you're going to see the same exact UI just in the browser, okay? So the exact same experience will be in there, right? That's an important part. The auxiliary stuff matters, and often matters more than the primary stuff. Think about, say, TypeScript. When TypeScript launched, did it become successful because the compiler was so amazing, or because you had LSP and editor support and refactoring, and the overall package was very nice? I would argue it was the latter, right? Lots of languages by that point had fine compilers, right? The compiler wasn't the strength of TypeScript. It's the auxiliary stuff that was the strength of TypeScript that, that made it what it is today, which is like a dominant thing in the JS space, right? Okay, let's keep going. So everything I show you so far in terms of kind of ergonomics is human-centric, right? Humans configure stuff, humans look at graphs, humans do all of this stuff, right? 2025, so we have to talk about AI because, everyone uses it. I use it myself every time, right? And I like this quote by Alan Kay, whom I really like, which is context is worth 80 IQ points, right? And I think he didn't say it in regards to AI, but I actually think it applies. Like, context is everything. And as I mentioned, generally speaking, if you are in an enterprise that has 20 repos that comprise one system, like one banking app, for example, if your AI agent looks at one of them, it's missing most of the context, right? Its utility is very limited, right? So if you do what some teams try to do and say, I'm going to have my basic monorepo tool, right? And I'm going to just throw a bunch of code inside, right? And wait, maybe my AI agent will figure it out. Well, it won't figure it out really well, right? Because it's just like a big pile of code. And LLMs don't actually do that well with big piles of code. And agents don't do that well. They get overwhelmed. No matter how big the context window is, they claim, the degradation of quality is substantial once you pass a certain number of tokens, like 30K tokens or whatever, right? So you don't want that. So what I showed you with all the graphs that you can see as a human LLM we also see with the next. Like we are going to feed the same graph to your LLM. That's an important affordance right now, such that when LLM looks at your monorepo, it sees what you see. You see a sophisticated graph with a bunch of metadata. LLM sees the same metadata just as a massive JSON document or like many small JSON documents, right? And the outcome is actually quite interesting. So what we see as an outcome, this is a metaphor I use, is that without this kind of extra metadata, an LLM thrown in a big monorepo, or like an AI agent thrown in a big monorepo, it's sort of trying to navigate a big city, but only using the street view. It kind of knows where it needs to go, but it doesn't have a map. So it has to drive around and figure it out. And it may figure it out, but it's not going to be the best experience, okay? What you want and what we try to provide is build a very comprehensive map, right, with a lot of metadata and feed it to an LLM. And then with that map, the ability to navigate, in this case, in this metaphor, are drastically improved, right? I will kind of show you just a little bit what I mean. This workspace. This is not a very good example. It will just illustrate that it works. But the important value in here that I don't want too much time, demoing because I just don't have time to demo it. But it's really cool is that once you start asking questions like create a new utility for the API, it will know what API depends on what packages, which teams build it, and it will create utility in the right place using the right samples, right? That kind of contextual stuff that you don't normally have, you will have in here, right? And it's a big deal, makes a big difference, okay? So in general, the AI stuff is important, right? You have to do it for agents, not just for humans, okay? Okay, last part, that is the most exciting to me because I really like talking about CI, and that's kind of the main struggle with monorepos, I think, is CI, right? Monorepos can break all your silos. Everyone, is together happily, dancing, sharing code, and everyone is happy, and it's like 1960s again or whatever, right? And but an AI is happy, can see everything, it's super powerful, and great things are happening. Okay. The problem though is that monorepos by construction get more and more useful the bigger they become, right? You don't have to be massive, but you have to have enough of the stuff in there for you to see the magic when suddenly you can make large-scale transformations efficiently. However, the bigger thing becomes, the bigger headache CI becomes, right? So you have to solve CI. You just have to. Otherwise, monorepos is going to be a strongly negative experience, okay? And solving CI requires a couple of things. The first one, you have to make CI fast, right? Because you just run a lot of compute sometimes because you change a lot of stuff, right? Fast, by the way, is not the hardest thing to do. The second part, you have to make CI reliable. And reliability actually is more important than speed. So we can talk about it perhaps at a later point. If you grab me somewhere at some conference, we'll talk about reliability in CI, right? And why it's more important than speed. So we have to solve both of those, okay? And unfortunately, people don't do it super well, I think, right? Because if you think about it, any sizable repo, and a monorepo to provide value will be a sizable repo, will have to require a lot of machines to run CI, every single CI run, right? How many probably should vary based on the PR size. Some PRs will be small, maybe require a couple of machines. Some PRs will be massive, maybe require 50 machines. I don't know, right? You have to vary, right? But they will require many machines. Those machines have to exchange files, right? Because you're not just doing things in isolation. Presumably, you like one thing is built for another thing to be consumed, right? And most monorepo tools in the JavaScript space in particular, outside of the JavaScript space, if you look at Bazel and stuff, they do it correctly, as we do, right? But most monorepos in JavaScript space, they're super focused on one machine, right? They're saying that we're going to optimize your things on this one machine super hard. The problem with that is most of the gains in this picture are not in optimizing tasks on one machine, right? It kind of almost doesn't matter, and also all tools do it reasonably well on one machine. It's not that hard to lay out sub processes correctly, etc. That's not the hardest part. The hard part, that's why if you do it, is looking at 20 machines and optimizing compute across this grid of machines and figuring out how to spread the compute such that no machine is idle, that you kind of run compute as much as you can, chop it up in smaller bits, whatnot, right? That's the hard part, but where the gains are, right? So it is a hard part. So I think that sometimes the monorepo tool authors kind of the famous, you look for the keys under the light sort of thing. We are solving this small problem that is not a problem, but the real problem is this, and very few people try to solve it, although some do. We're not the only ones. So to show you how it works, and I'm going to very quickly pretend to submit a PR. The reason why I pretend, because I don't want to waste people's time. So essentially, the original title was this. I added something to this application, and I sent a PR, okay? This is the PR. Okay, I did it again in advance to save people's time of my trying to type in, opening pull request, and and other things. Okay, this is the pull request. It's very simple. It changes the title of the application. Okay, so it's very good for illustrations. Okay, so this pull request requires you to run OTN test or like build the API, because API is used by the app. The whole thing has to be reworked, right? And if I look at this CI execution, you'll see that it took about 2 minutes to run it or whatever. But it ran across 3 machines. It was 3 machines, 3 agents in this case. We call them agents, also not AI agents. So agents as in compute agents, okay? And those 3 machines took the compute required to run the CI and divided between themselves in a smart way, okay? And they ran this compute. You as a developer don't care. From your point of view, the flat list of tasks, it could happen on 1 machine, it could happen on 30 machines, it could happen on 50 machines, doesn't matter, right? It appears flat. There is a single machine experience you get, but actually compute is spread out, right? And it's spread out without you having to configure very much, right? So the only thing I have to do is basically say, hey, I would like to, in this case, it's a static number of machines. In reality, for a real project, it will be a variable number of machines based on PR side. It will be different classes of machines for different types of tasks, etc., etc., right? So all this stuff happens automatically for you, right? There's a cross-site distribution without you having to do very much, right? And you get kind of the scalable CI that doesn't require you to think about it very much. The important part here is, though, if you look at it, you will see that my CI failed. I screwed up, right? I forgot to update the test, right? I changed my title, but I didn't update the test. And I'm super out of time, so I'm going to be speaking even faster right now. So get ready, folks, right? I forgot to update the test. Thankfully, right, we fixed it. We figured out that you forgot to update the test, and we provide a solution. How this happens, we can talk about it separately, but it's a tricky problem to solve, right? Good in-flight CI fixing that actually runs on the right machine, it does the right fix and considers the right context is a hard problem to solve. It is more important for monorepos, because in the monorepo case, those type of failures are a lot more common because you tend to do a lot more stuff, okay? Let me go through my conclusions and we'll be done. 1, core experience matters. What matters more is secondary experience, because a lot of tools can nail the core experience, do stuff around it. People love IntelliJ. I do love IntelliJ, not because necessarily it like runs my compiler super well. It's all this stuff around it that makes it an enjoyable product to use, right? That's why everyone is so loyal to it, right? Don't ignore the auxiliary experience. Steal ideas from people from adjacent domains, like we stole from editors. Toyota stole its ideas from American supermarkets to do just-in-time everything, and they became the most successful car company in the world. So not steal, borrow ideas, okay? Be inspired. Provide symmetric experiences for humans and AI agents. Everything you do has to now target both things. There is no choice, right? 4, monorepos can really make your agents 10x more powerful, because they can affect a lot more code, but it has to be done right. You have to give them the map. Finally, CI is not an afterthought, right? If you're building a build tool for monorepos, it has to solve CI. No matter how cool your AI is and TUI is and whatnot, if you cannot merge, it does not matter. Go to websites and follow me on social. Thank you.
Hey, that was fantastic. Let's bring us all on screen real quick. Especially that last part, CI, it is not an option. It is how you get to production. A great way to end it. That slide where you said, I wish I had more time to talk about fixing that test. I wish you did too, because I thought that topic would have been absolutely fascinating.
That is actually the coolest thing. We can maybe someone will ask a question, we'll see.
Yeah, sure. Or come back next year and fill us in on that. I thought it was hilarious about you having to be told not to run npm install during your demo.
Yeah, npm install, or like a lot of things could happen. Okay, I could be hacked. You don't know. So
sure. We have a question about what are people seeing with monorepos. I just want to flash up one of the answers that was given. Forking and merging is the hardest part of repos, and I just wonder if other people out there have a similar feeling about that. I also wanted to bring up a comment on your point. Not only is he the GOAT, but your point about context is 80% is fantastic.
Well, can I say, honestly, anyone go to YouTube and just search Alan Kay talk. Find any talk by Alan Kay, no matter what the talk is. It's brilliant everywhere. Just watch any talk by him. It's just great. Okay, honestly,
I will ask you I'll ask you one of the many questions I wanted to follow up on because I'm really interested in this. You talked about this is the directory where NX will cache things. And then you started talking about caching. How much of the performance win comes from having a reliable cache? This question comes from a former Gatsby person who could never trust their cache.
It's a very good question. So first of all, you never trust your cache a lot of the times, right? If you have to configure your cache by hand, right? Because like the more that's kind of one of the things I try to point out is that you never configure the cache. The cache should be derived from the tool that you use, right? Because you have to configure your tool to work correctly. The cache should be just a byproduct of that, right? If you have to configure your caching by hand, it means you have to configure something twice. And humans are not good at configuring things consistently. It's the reality, right? Like that's one thing in terms of like you need to trust your cache. Now, let's say your cache is trustworthy, and I think you can get to a trustworthy state. Cache is a good thing for like P50 of your CI times, right? Because you get kind of partial updates. Some parts will be cached, some parts will be loaded. Very useful. You have to have the cache because that's kind of cache is very easy. I mean, very easy. It's reasonably easy to build, right? I would argue it's kind of hard to build in a safe way, but whatever. It's straightforward to build, and it's a lot of gain, right? But it doesn't help you with P95. When you change something that affects a lot of stuff, like nothing is cached. So if you have an occasional CI build that takes 5 hours, it's still not acceptable. So that's why distribution is fundamentally required. Cache is more like a very, 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 very nice to have, but not required.
Okay, well, I wish we could talk a lot more about that topic. In particular, NX is mature, and you've probably gone through these cycles of figuring out the long tail of all the things to wire in or to wire out after wiring it in and deciding that it was more trouble than it's worth. But we'll have to say that for the next time because we're in our break. Victor, thank you very much.
Thanks so much, folks.
Thank you.